Oh my goodness. I do one problem and Dad's in the chat. Katesh Tosh has subbed with Twitch Prime. And did I lose a VO? What's a VO? Oh, did I lose a V-Knot? I don't think I lost a V-Knot. I just might have drawn it poorly. And Gatesh Tosh, thanks for making my taxes harder. Oh! An ice cream man? Ice cream man? Maybe? Thanks for the follow. Oh, I did, but then I found it again. That V-Knot right here. That was an annoying problem, though. That was a long one. Like, you gotta make sure you know what's going on if you get that problem. Pain. Blaine is a pain. Cool. Oh, maybe you're talking about this V. You're talking about this one? The squared? You know, like mechanics? I love mechanics. It's just a lot. There's a lot of little things to remember. Ice cream man, this is for you. This is for ice cream man. Ice cream! Go to the E&M problem in a second. May the gradients be with you. Orion, what are you doing? You competing with Dad for bit whatever that is? I have no idea. But best of luck, Dad, with that calc exam. Oh my goodness, stop. You're not going to stop, though. You two have nothing better to do. Other than study for that calc exam. Am I able to cheer for myself? Am I able to dump fake bits upon me? My friends are all saying that in a binge watching bracket, 30 Rock would win. And The Office lost to Breaking Bad. I don't know. I wasn't a huge fan of Breaking Bad. Let's do Calc 3. Calculating the curvature of a function. Do I ever remember how to do that? Let's see if I remember how to do that. Curvature of a function. Paul's online math notes. Glad they're still there. Let's see. Here, we'll do this example. We'll see if I can figure it out along the way. Sometimes I get bored and it's fun to do stuff. Curvature with a K. Let's see what's going on here. We know that curvature is equal to derivative of the tangent over ds, where ds is an arc length, right? Or s is the arc length, so it's a tiny bit of the arc. And then, yeah, if you're doing, yeah, you can do it like that. So let's see. How do we determine the solution for r of t, which equals, in three-dimensional form, t, 3 sine t, 3 cosine of t. So let's do this. Actually, we could also write this if we wanted to as r prime crossed with r double prime over r prime cubed. Yeah, I mean, you never do. You just reparameterize it if you can. I think I'm taking this derivative correct. Did I do that right? Did I take that derivative right? Yeah. Then how do I find t? How do we find the tangent vector? Tangent vector, tangent vector. Oh, I need to find the absolute magnitude of the first derivative. And then I need to take 1, divided by the norm. So the tangent vector is what? R prime divided by the norm of R prime, right? So this norm of R prime is going to be equal to the square root, because it's just a Pythagorean theorem, of 1 squared plus 9 cosine squared plus 9 sine squared. And then cosine plus sine squared is 1, so we pulled a 9 out on them. So we get the square root of 10. So then this is going to equal, the tangent vector is r prime over root 10, which means that our tangent vector over here is going to equal 1 over root 10, comma, 3 over root 10 cosine of t, comma, negative 3 over root 10 sine of t, right? Right. I think that's right. And then we want to find t prime. So t prime of t equals, well, that's going to be 0. This is going to be negative 3 over root 10 sine of t, comma, negative 3 over root 10 cosine t. And then when I do t prime and r prime together, because it's, wait, is it dt over r prime? What is it again? Why did I put a d there? I didn't mean to put a d there. It's t prime over r prime. I do t prime over r prime, which gives me 0 over 1 3 over negative 3 over square root of 10 cosine over sine, so it's a cotangent. I think I'm dividing this right, question mark. And then, wait, is it t over r? Snap. Oh, it's t over r. Did I do that right? Ah, no, I didn't. Wait, I didn't do this one right. It's t over r. T over r. So 0, 1, yeah. But then it's negative 3 over root 10 over 3 sine over cosine is tangent, comma, and then yeah, and then negative 3 over root 10 over negative 3 cosine over sine is cotangent. I think I'm doing that right. Oh, no, I'm doing it wrong. Oh, crap. I'm doing it wrong. You're doing it wrong, bots. It's the magnitude. It's the magnitude of t prime over the magnitude r prime. Duh. So that's root 10. So then I need to get the magnitude of t prime, which is Pythagorean theorem of 0 squared plus 9 over 10 sine squared plus 9 over 10 cosine squared, which is 9/10. So I'm going to get 3 over root 10, because square root of 9 is 3, root 10 is 10, all over root 10, right? And then when I divide, I take the reciprocal of the denominator, so I get 3 over 10. Bam! There's my curvature. I don't know what that means. But if I recall, I am pretty sure that this initial function here, if I'm correct in 3D, this here is going to try to make a circle, but this is going to push the circle. So you should have a shape that's like, depending on your orientation, that's like, it's like that. This is giving me war flashbacks. Yeah, well, how do you think I feel? I don't even remember that curvature was a thing. I had to look up an equation for it and then try to rederive it on the spot. I didn't even remember for a little bit that this was a thing. Like, that's just fast way of saying Pythagorean theorem. Like, man. The war was so long ago. Yeah, it does get super long and tedious. Like, there's no way it can't. Because you're just taking, like, a derivative and then, like, you got to do a Pythagorean theorem on it to find the magnitude of that vector. But I'm glad we could do a little bit of a problem for you, Dad. Get you a little bit caught up. A little bit of review tucked in there of that helical shape. Because, you know, why not? I think technically it's my lunch break and I have forgotten to eat again. Did I finish all those peanuts? I did. What is exponentials? You just skip it. Would exponentials be difficult? Here, I want to show you this, Dad. I don't know if you'll be able to do this because your test is literally today. But if you're given a function, I don't know if you're familiar with Jacobians, but we did cross products a while ago. Let's say you're given this as a problem. It's like t squared and then t and then 0, which is the same way of writing t squared in the I hat direction plus t in the j hat. Or no, let's do this. I'm going to follow Paul's online notes here. So we'll make it a 0 in t. So this is t in the k hat direction. What you can do is if you take the first derivative of this, then that's just going to become 2t 0 1, right? And if you take the second derivative of this, you're just going to get 2 0 0, okay? Another way that you can solve this, instead of doing the magnitude of t prime over r, is you can do this, r prime cross r double prime, and then take the magnitude of that. So if you set up the ij matrix of 2t 0 1 and 2 0 0, I don't remember if you remember how to take a cross product like this. But if we just look at the cross product of this 3x3, then the way we do this, if I'm recalling correctly, is we go left to right and then left and right, and J and K, or then right to left, and J and K will oh snap. The exponential you gave me looks miserable. But what we basically see here is that we're going to get 0 I hat, and then it's positive, negative, positive. So minus, and then it's going to be left, right, and then right, left. So 2t times 0 is 0. So it's going to be 0 minus, and then 1 times 2 is 2 in the j hat direction, and then plus, then we do left and right, which is 2t times 0 and 0 times 2t, which gets us 0. So we should just get at the end of this here, the negative of negative 2 is positive 2, so we should just get 2j hat, and that is what equals r prime cross r double prime. If you want then the magnitude of this quantity, that in that case will just equal 2 because there's nothing else to give it by, which is kind of neat. And then all we have to do is we take this quantity and divide it by the magnitude of r prime, and we were given it's the magnitude of r prime cubed. So we knew that r prime was, wait, is it cubed? Is that a cubed value? Yeah, it is cubed. We know that r prime is 2t plus 1, well, when we're doing the magnitude of it. So the magnitude of r prime equals the square root of 2t squared, so that's 4t squared plus 0 squared is 0 plus 1 squared, so we get that. Which means when we take this here, we're going to get 2 over, and I'm just going to write it like this, it'll be easier, 4t squared plus 1, and then this is to the 3/2 power. So that's another way you can do it if you're familiar with doing matrices and finding, not Jacobians, but determinants. That's what we're looking for. This is a 3x3 determinant here in the I, J, and K direction. You do a lot of this in Physics 212 at Penn State, the E&M class, I think. But you could also do it like that if you have nice functions. How do you do? What's this? This is e to the 4x plus 6y squared. I think you have to reparameterize this. Yeah, you do have a t in the answer here. Yeah, you have a t in the answer. Yep. And that's fine. That means something in the world of curvature. I can't remember what it means. But it means something. So you can find the curvature at a value of t. So if you say, like, what is the curvature at t equals 2, you can plug it in and find the curvature at that point in time.